All right, and welcome to Rational Equations, Level 4. Now, in this example, we're going to solve it essentially the same way that we've done for our Level 2 and our Level 3, and it's just going to be one step harder. So, notice I've actually rewritten this entire rational equation, but the one thing that I have not rewritten is this x squared minus 25. Remember, in order to combine these two fractions, we need a common denominator. And in order to do that, we first have to factor this quadratic. Well, if you will recall, we know that x times x will of course give us x squared. And noticing here there's no middle term, there's no x value, this is probably a difference of squares. And so we want to say, okay, well, what does x squared minus 25 break up into? And we should know at this point pretty well that that will be x plus 5 and x minus 5. Now from here, in order to combine these two fractions, we need them to have common factors on the bottom. So see how they both share an x minus 5. That means that this one is simply missing this other factor of x plus 5. So let's multiply the bottom here by x plus 5. And of course, what we do to the bottom, we have to do to the top, x plus 5 again. Now, once we have all three denominators are the same, remember they don't go away, but in solving this you can ignore them for the first portion of this. So let's go ahead and distribute right here. We have 6x squared times x, which will give us 6x cubed. And we have 6x squared times 5. Well, what is 6 times 5? That gives us 30x squared. And remember, anytime you see a negative in front of a fraction, it means you always have to distribute that. So a negative times a positive will give us negative 27x squared. And, let me make that just a little bit neater. And a negative times a negative will give us a positive 2x equals. Now on this right side, we can go ahead and keep this negative 4x squared, because this really doesn't change. Negative 4x squared plus 5x. And notice we actually have a relatively complicated equation right here. So let's go ahead and start by doing some simplifications. Thing number one, I want to combine my like terms. So I could write this as 6x cubed plus, and ask yourself, what is 30 minus 27? Well, that would be 6x cubed plus 3x squared plus 2x. Now, kind of for space's sake, let's go over here to the right. We know that whenever we have a quadratic or a higher power after that, which in this case we have a cubic function, we always want to set it equal to 0 in order to solve. So, how can we get rid of this negative 4x squared? And we know that we would add 4x squared. So I add 4x squared. And why don't I do it this way? I'm going to add it over here in line with this. 4x squared. And once again, I apologize for the stylus issues. And how do we get rid of this positive 5x? Well, minus 5x. So here I can write minus 5x. And of course, we're setting this all equal to 0. Well, now let's go ahead and simplify this one step further. And we see here, let's see, we have another x squared that we can combine. So we'll have 6x cubed. And then what is 3x squared plus 4x squared? Well, of course, that would give us 7x squared. And we have a 2x minus 5x. So what is 2x minus 5x? Well, that would be negative 3x. And we're going to set this all equal to 0. Now you'll notice I've kind of ran out of a little bit of space on the right. So here's what I'd like for you to do. Pause the video, finish taking any notes that you need to, and I'm going to erase everything on the right side so we have a little bit more room to work with. Now, as you're finishing writing these notes, or maybe you've caught up, I want you to ask yourself this question. Since we typically don't deal with solving cubic functions, what is one term that could be factored out of this equation that we wrote? what is something that all three terms have in common? Maybe it's a number, maybe it's an x. What do you think? Okay, almost there. Okay, so switching back, we see that every single one of these has at least one x to give up. Now, unfortunately, 6, 7, and 3 cannot be divided by the same factor, so for this one, we will simply factor out an x, and everywhere that we factor out an x, the power of x will drop by 1. So for instance, this is x cubed. Well, it now becomes 6x squared. Here we have a 7x squared. That just becomes plus 7x. So whenever we factor out 1x, we're essentially just dropping everything down by 1x. Negative 3x simply becomes negative 3. And of course, this equals 0. Now, how will we finish this problem off? We have to factor this right here, 6x squared plus 7x minus 3. And this is actually slightly difficult because this is something that we'll have to solve with factoring by grouping. How do we do that? Well, we take our first and our last term, 6 times negative 3. Let's see, 6 times negative 3 would give us negative 18. And then we want to figure out what two things multiply to be negative 18 but add up to be this middle term of positive 7. And that's going to wind up being positive 9 and negative 2. So how can we write this out? We can write this as x parentheses 6x squared, and ask yourself which number, 9 or negative 2, will best go with the 6. Well, 6 can actually be divided with the 9 or negative 2, and I look over here and see a negative 3. This would go better with the 9. So let's go ahead and write minus 2x, and then we'll take this positive 9, we'll write plus 9, and then lastly, we'll write this minus 3. Okay, and don't forget there should be an x right there, closing that parenthesis. Now I know this is all kind of cramped, and I do apologize, but remember what we want to do with factoring by grouping is we want to take our first two terms, put them in one group, and our next two terms and put them in another group, and from here we want to factor out the greatest common factor of each. So here's how I'll write this. I'll write x with a giant bracket, and when we look at this factor of 6x squared minus 2x, well, what's the largest factor we can pull from both of these things? Well, 6 and 2 can both be divided by 2, and x squared and x can both be divided by x. Now when we pull that out, we're left over with 6 divided by 2, that'll give us 3x, and negative 2x divided by 2x will give us negative 1. Okay, now here from 9x and negative 3, the biggest term we can pull out is that positive 3. Let's write that. And what is 9x divided by 3? Well, of course, that will be 3x. And what is negative 3 divided by 3? That will be negative 1. Now notice, when using factoring by grouping, we can now set it like this. X, which has always been on the outside since we factored it out originally, times, we take our two leading terms, 2x plus 3, and this last one, this factor that they both have in common, 3x minus 1. And of course, this is still all being set equal to 0. Okay, now at this point, this is incredibly cramped. So here's what I want you to do. I want you to keep taking the notes. I want you to pause the video, and I'm going to erase a lot of work that we've done so far so that we can have room to write some more. So once again, please, please, please make sure that you are taking these notes as I erase them. So one thing should come to mind, that as you're taking these notes and you're thinking about what are our next steps going to be, is we understand that this cubic function there to the right is all being set equal to 0. So essentially, we want to take every single factor there, all three of them, and we want to set them all equal to 0 to figure out what solutions we're going to get from this. It's almost there. Do need to find a faster way to erase this, by the way. Fun little tip, what you can do is you can click on the right side of your screen. If you click it twice, it should send you forward by 15 seconds. And you can actually click on the right side of your screen twice and keep repeating that until you get past me erasing all this if you would like to skip ahead. I'll figure out a more efficient method of doing this in the future. Okay. All right, good enough. All right, so let's go ahead, switch back. Well, let's kind of rewrite this out. So we have x, parentheses, 2x plus 3, times 3x minus 1. And all of that is set equal to 0. So how are we going to possibly find our solutions? Well, all we have to do is take each one of these three factors and set them equal to 0. So for example, our very first factor on the outside is this x, so we'll do x equals 0, and notice x is already by itself. We've already solved. X is simply equal to 0. How about the second factor? We have 2x plus 3, and we want to set that factor equal to 0. Well, how do you solve that? We have a minus 3 and a minus 3, and of course that goes down to 2x is equal to negative 3. And how do we get the 2 by itself? Well, we divide both sides by 2. And so it turns out our very next x value is going to be x equals negative 3 over 2. Okay. Now I really don't have the room to finish out this very next example, which is this 3x minus 1 is equal to 0, without erasing again. So here's my challenge to you. I want you to see, can you take this factor, can you set 3x minus 1 equal to 0, pause the video, solve for x, and then once you have it, unpause the video and see if you get this value right here. So please pause, work it out. But if you worked it out correctly, x will actually equal positive 1/3. And so these are going to be our three solutions to this incredibly difficult rational equation. Now, one final thing, and you might have remembered this from our previous examples. We always have to take these three values of x, and we want to plug them into the factors of our denominator to make sure that they don't equal 0. And so, in this case, let me just give you a quick little tip on how to do that. We know that our original factors in the denominator were x plus 5 and x minus 5. And notice the only things that could possibly make these factors equal to 0 would be a negative 5 and a positive 5. And since none of these are positive 5 or negative 5, all three of these are valid solutions. Alright, I hope this one helps. And you only have this one plus 3 more problems. This should be fairly simple so long as you really take your time with this. Alright, good luck.